Now, one more note on solving these eigenproblems is that so let's write what we're doing here. What we developed before was a minus lambda b multiplied by this chi vector, those are eigenvectors, is equal to 0. Okay, so in general, we're going to use numerical methods to solve this, so you'll be plugging this into a numerical algorithm. Well, some algorithms actually only accept a single matrix. Instead of an A and a B matrix, they only accept a single matrix as an input. And the reason is because we can actually rearrange what we have here. So if we multiply through by the inverse of B, so if we do B minus 1 times A, and then minus lambda times B minus 1, the inverse of B, times B, there's our chi equals 0. Well, this is just the identity matrix here, right? So, so we can actually rewrite this whole problem as B minus 1 times A minus lambda times the identity matrix times chi equals 0, where this first matrix is the inverse of B multiplied by A. So I'm just going to call that C for the time being. So we could put in something like C minus lambda I equals 0, okay? And so a lot of numerical eigensolvers only accept a single matrix, and that's really not a problem. We just need to compute that by using the inverse of B times A, okay? And then we plug that in for that single matrix that it accepts. So strictly speaking, a single matrix does not have eigenvalues, but it's really this system of equations that does have eigenvalues. And so, but people will often say, what are the eigenvalues of that matrix? And what they mean is if you plug that matrix into this system here, what eigenvalues and eigenvectors do you get out? Anyway, that's kind of common phraseology, but we're going to be working with two matrices here, and using those as a system of equations. But I just wanted to show you that you can plug those, you can combine those two into a single matrix and still plug it into this system here to solve for the same eigenvalues and eigenvectors. Get out the same one. This is called the special eigenproblem. If the second matrix is the identity matrix, then this is called the special eigenproblem. And a lot of solvers may not require that, but that's usually, I would say, a default in those solvers. So so when you're using MATLAB or Python or whatever you're using to solve this, just be aware that by tradition it probably is only going to accept a single matrix, and so you'll need to pre-multiply these together and then plug that in for that single matrix, and then it will solve then for the eigenvalues and the eigenvectors of the system.